Hey everybody, welcome to episode 2 of our American Bosch Model 28 Essex radio that we're restoring. In the last shorts video I showed you that we're cleaning it up and it's coming along really nicely, so no problems there. Today we're going to take a look at the power supply. The goal is going to be to figure out how we do the electrolytic capacitors and maybe do a quick little power up test to see if it works. Alright, so let's take a peek at what we've got and hope you enjoy. Thank you. Hey everybody, hope everybody's doing well. So in the shorts video that I put out the other day, I showed you the cleanup that I was doing on some of the internal components. Today we're going to focus on the power supply of this American Bosch Model 28 Essex radio. And what you're looking at here is the power supply section. One of the things that I said in the other video was that I was really impressed that in 1928 they built this thing to be modular. In other words, there's a separate power supply that connects with a connector to the RF section of the radio. So this is a self-contained unit. And in this unit you have your filter capacitors, your transformer, your rectifier, and your audio output. Now this radio doesn't have any speaker, so we have to figure out what kind of speaker we need on this, but that's going to be for later. So what we're going to do today is we're going to replace the capacitors. There's two capacitors in this thing. There's a 2 microfarad and a 4 microfarad. And think about 1928, how large they would be. So that's going to be interesting. I'm going to see if I can upgrade the value of those things a little bit. I have to take a look at the tube data for the rectifier tube, which I think is an 80, actually. I have to look at that. It's an 80. So I can probably go up to a little bit higher on those things just to help smooth out the current a little bit. But let's not worry about that right now. Let's focus on the capacitors. So this thing has everything here, and we have the cans. So on this side is our capacitors and a filter choke, okay? And this side is the actual transformer. Now what I've done is I've already taken off the can that contains the capacitors. Let's show you that. It's right here. Of course it's in the tar, right? So there's the choke, right? And the choke coil, and then the 2 capacitors. Now, the instructions that I have right here says unsolder the 5 leads of the filter can at their point of connection. And as you can see, I have more than 5 here, but not a problem. So here's how it works. There's 3 blue wires. Only one of these blue wires is connected to the capacitors. So this is a common ground. So it's this one is the common ground. The red one is our 2 microfarad cap, and this black one is our 4. So that's our capacitors. So if we snip those off, we're good to go. These 2 wires right here are the choke, and these 2 blues go to ground. I don't know where they attach to. They don't go to the capacitors, but we're going to put them back where they were because there's nothing attached to them. We're not going to do any harm because we're cutting this off. And then these parts go back to the transformer. So that's independent. So all we're going to do is snip these leads off. I'm not going to melt the tar and take everything out and restuff it. I'm going to mount the actual new capacitors right here. Again, you see I have a terminal strip already here, so I can put them on the terminal strip, or I can put a new terminal strip here and just mount them here. So that's how we're going to do it. So we're not going to go crazy melting tar. Okay? It's amazing that these things were made to be replaceable like this. So we're going to cut our leads for our capacitors that are in the can. Gone. Gone. I've already measured all this, guys, so I know that these are the right ones. So our capacitors are now out of circuit. Okay? So all we need to do now is reinstall this back into the radio, into the power supply section. I want to make sure I get those nice and done so there's no exposed wires. And all we need to do is put this back into the power supply, and then we can mount the new caps, and then we can continue. We've got some resistors that we need to check. Show you that right here. There's a bunch of wire wound resistors right there and here. I have no idea if they're any good. There's also a couple of resistors here. Here's a 5K, and this is 1.2K. So we're going to need to check all those. So let me get this thing remounted, and we'll take a look and see what the new capacitor setup looks like. Okay, so I have our electrolytics tacked in. I used a pair of 4 microfarad caps here, and they're tacked in. I want to make sure I test this thing first, and then I'll mount them permanently here. But I'm going to leave them tacked where they are for now. Next, I need to replace all this wire. This wire goes out to the power switch and the indicator bulb, and a couple other things I need to address. Let me show you this real quick. So when I first got this set, I didn't really pay much attention to it, but I said there's 2 power leads that are cut. I couldn't imagine why, but thanks to our friend Brendan, he told me that one is obviously the AC power line that plug into the wall, and one is where you would plug in a speaker, right? So you'd need a speaker with a field coil. So need to think about how that's going to work and what's required for that. But aside from that, I'm going to start testing all these resistors over here, making sure that everything is where it's supposed to be, and I'll ohm out everything, and then we'll do a test possibly and power this thing up after I change some wires. That's kind of where we are, guys. I'm going to do a little bit of this cleanup here on this stuff, and then we'll take you back. Alright, we're going to do an initial power up on our variac and dim bulb. So I've got everything wired. I've replaced all the wires for the switch. However, the switch is bad. So right now I just have a loop of wire on here, and I've got a replacement switch coming. And I've rewired the indicator lamp as well. So we're going to put this thing on the variac. I've got my meter connected to what they're calling here plus 90. I don't know what we're going to get. Probably going to get more than that because there's nothing else connected to it. But let's see what comes up. Let's go up really slow. Alright, so we've got power on. Okay, and we're going to slowly bring up the variac. We've got 30 volts. And I don't know if you can see that, but I do see the bulb glowing a little bit. Right there. That's good. And we're starting to climb up here. We're still at 30 volts. That's a good sign. The bulb itself is fine. Nothing happened in there. Let's go up a little more. Let's go to 50. There's 50 volts right there. You can see our lamp is lit up. That's good. Already at 138 volts. I'm not going to worry about that right now. So far so good. I don't see any current draw. Let's go up to 80. We're up to 217, a 218. Our bulb is nice and bright. Now let's bring this down and go off a dim bulb. We know we don't have any shorts. Let's go up to 60 for a second. And remember, there's no load on this thing. Let's go to 90. Let that bake for a second. Okay, good. Let's go up just a little bit more. 100. Alright, we're not going to stress out the transformer any further than that. So we know that we have no shorts in this thing, and if the capacitors are working and we're getting rectified voltage, I do notice right here that there's no bleed down resistors. That means we've got a couple of 100 volts under there. So let's bleed this down a little bit. I've got my little tool here that I use for that. Watch the meter. We're just going to touch the lead right here. Okay, good. Alright. Okay, so our power supply section seems to be in good shape. We need to put the switch back in that I was telling you about. And then I've got to do some other checking underneath there. Let me show you the bottom, what it looks like before we wrap up. And we'll go from there. Okay, so here's where we landed. Here's our wires that we replaced for the switch and for the indicator light. Here's where we've wired in our, this is our AC line here. I'm going to replace that cord, but I've just got that tucked in for now. Here's our electrolytic caps, and for now I'm going to leave those where they are. Again, I'm going to mount them here permanently later, but at least we know that at least the power section appears to be working. I don't know anything about the output transformers or what those are doing. We'll have to figure all that out later, but for now I think we're in good shape. I didn't have any audio tubes in there, by the way, so this also contains the audio tubes. So no problem there. So at least we know we got the power section in a good spot. So now I'm going to keep playing with this thing and make sure everything else is good. And in the next episode, perhaps we'll try to connect it to the other section and see if we get anything. But first we need to figure out what kind of speaker we need. We know it's a high impedance speaker. I did measure across the speaker jacks and I'm getting like 1.7K, so I definitely need a high impedance speaker. Need to figure out which one, and I probably need to put a matching transformer in there. We'll talk about that in the next episode. Alright everybody, have a great day.